I would like to go on the journey with you today. And as already said, we have a huge challenge in front of us, and the challenge is to decarbonize the aerospace aviation industry. And this challenge cannot be just solved by one person, by one company, by one country. It has to be solved by the ecosystem. And this challenge has to be solved by 2050. We committed by 2050 that the aerospace industry is going to reach net zero. And I like to always look a little bit back in order to understand what is going to happen during the next 20, 25 years. And I remember it was about 23 years ago. It is my mobile phone, Nokia 6510. And probably many of you guys had the Nokias as well. And if I compare this phone to the new iPhones or Samsungs or you name it, then the screen resolution changed about 1,000 times during the last 2.5 decades. The memory which we have, or processor, is about 30 times faster on the new phones. And memory is about 300,000 times more compared to this what we had here. The only one common thing which remained between these two phones, you still make the phone call with them. But that's it. And now I asked ChatGPT to create the future of aerospace, how it's going to be looking like in 25 years from now. Is it going to be really different or not? And you can see it on the screen. On the one side, we see that the industrial systems are going to be more automatized. We are going to have more AOTs inside with some humanoids which are working around the airplane. And then, of course, we are going to be flying also different kind of the airplanes as well. And those airplanes has to be different because we have a common challenge. The challenge is that, first of all, during the next 20 years, we are going to have double as many aircrafts in the service. It is based on the global market forecast, which is prognosing that this is going to be amount of the aircrafts which we are going to be flying. Today it's about more than 20,000 or 22,000, and then in the 20 years from now, we are going to have more than 46,000 aircrafts. This would mean that on the one side, we have to bring more these beautiful birds into the air. On the other hand, we have to also ensure that we do it in a safely way, and we are going to do it in maybe not yet in quite regenerative, but it would be not bad if we are already including this into our next generation of the aircraft. Therefore, they are going to happen in few things. There's no one solution which is going to be solving this net zero challenge by 2050 by having double as many aircrafts and all of us stepping from time to time into this fantastic time machine and just during the couple of hours being in completely new place. And we would like to keep it because this is about the connectivity, and connectivity is what makes us human better person once we are experiencing new cultures, while meeting other people, while we have from time to time opportunity not just being in front of the screen, but having a nice drink together like yesterday evening. And there are a couple of the things which are going to be happening. The one of them, of course, is the exchange of the latest generation of the aircraft. It means the new aircrafts which we have already today, compared to this what is flying something like 20, 30, 40 years already, has at least 25, 30% better efficiency. And it's important also to say that this journey about decarbonization started already many years ago. It means if I will look last 20, 30 years, this industry already did the huge step towards this. It means reduce already about 50% the carbon footprint. But now the next 50% has to happen during the next few years, or during the next 2.5 decades. Now, operation and infrastructure is another one, because more aircrafts and having the safety and knowing that air traffic management system which controls all of these aircrafts is still very analog based. This is going to be different, it's going to be more digital, but it's a very long way to get there. We did recently some experiment, and it was just following the nature. We look how the birds are migrating from the winter to the summer time, and when they are flying into the chain, then they are building the chain because the birds which are back into the chain are getting the uplift from the turbulences which the birds which are in front are generating. Therefore, what we did, we took the two 350s and we flew them from Europe to US, to the East Coast, and we put them not in the distance like today. Aircraft are flying about 30 nautical miles as a minimum distance, but we tried to bring them a bit closer, something like 3 nautical miles. And then what we noticed that the second aircraft, if it's placed in the right position and getting the turbulences uplift, is reducing the fuel consumption of about 4%. And it was a huge difference. The 4%, the 1% in this industry is a big number. Therefore, if you can do something like 4%, you are doing a huge step forward. Now, the question is, how we can make it work? Because it cannot be done in an analog way. You have to have a digital platform, how you are connecting those aircrafts and you are controlling them together. The next important step is all about sustainable aviation fuel. This is probably the biggest chunk in the decarbonization, which can happen from one day to another. Here, all our aircrafts are going to be certified for 100% sustainable aviation fuel by end of this decade. And this is something what will happen. But now the more interesting thing is about disruptive technologies. And disruptive technologies are going to be happening on the aircraft design. It means we have to reduce the weight, we have to improve aerodynamics, we have to have a new sources of energy, and liquid hydrogen is one of them. And the combination of this is going to help us to add another 20–25% into this optimization. And one example of, well, so we are following the nature. We are developing now very nice prototype in the scale, something like 1/3, where we call it extra performance wing. There is the wing, which is like more a glider, much more smoother, much more longer. And with this wing, we will be able already to improve our dynamics of about 10% at least. But there's a challenge. This wing will be too long to bring it to the airport and to come to the gate. Therefore, what we are doing, we are intersecting there, or we are putting into the wing that the wing is going to be folding at the end. This means at least 1/3 of the wing will be closing. And then with this, we are adding additional capabilities to control the aircraft during the flight and after the landing, but this requires a lot of the new sensors like LiDAR, for example, which are going to be detecting if the goose is coming in towards the aircraft, and then you are able actively to change the wing geometry in order to act with the new aerodynamics which is happening. And Zero-E, it's which we call our aircraft, which is going to be first zero-emission aircraft we would like to bring to the service next decade. By end of this decade, we are going to be flying prototypes. It's going to be liquid hydrogen powered. And liquid hydrogen means it's going to have a tank with liquid hydrogen, minus 270 degrees C. And then we are going to have the entire propulsion system, which is could be, in one case, the fuel cell based. In other case, it could be then, for example, burn liquid hydrogen or gaseous hydrogen in the turbine. But all of this requires a lot of data, because we are on the journey where without data we'll be not able to manage the new way how we design the aircrafts, how we build the aircrafts, how we control the aircrafts during the operation, and then of course the end of the life and what's happening to the aircraft afterwards. Every 350, which is flying every day, is generating about 2.5 terabytes data. It's a lot. And they are already today in use. And then machine learning models, which we introduced already many years ago, and now AI and Gen AI are going to be helping with the journey towards sustainability. I will give you a couple of examples today, what we are already doing and what is our ambition in the future. First of all, if we think about AI from Airbus perspective, we are thinking about in the 4 categories. The category 1 is everyday improvements. We have seen yesterday, you have a chatbots, or you have the kind, or which are managing the knowledge-based systems in the organization, or we have, for example, meeting notes coming from the meetings. It's standard things which are already operating. From this, it's important about improving the internal processes. Internal processes is everything what we do in area of the procurement, in area of the engineering when we are designing aircraft, in area of building the aircraft as well. And then around the product, it means we have to introduce the new technologies to our product. And here I will touch later on, like for example, more smart automation in order to improve safety of the aircraft. And this requires a lot of the computer vision technologies, which are also combined with generative AI. And the last one is about our customer. At the end of the day, what we do as our product has to serve our customers and it has to be as efficient and safe as possible. Therefore, from that perspective, we are having the solutions already today for our customers, which based on this amount of the data we are collecting and having in our own data lake, we are serving our customers in order to improve the availability of the aircraft and ensure that every time you are stepping on the aircraft, we are safe and we are getting to the place where we would like to get. Now, as I mentioned before, it cannot be done just by one company like us. And I strongly believe that in the era of the AI, generative AI particularly, we don't have other choice. We have to work with the other companies. Not only big companies, which we are already working with, but also with the small startups. And it was in the Ben's presentation before in the discussion panel that there is a value between corporate and the startup if they are collaborating. Of course, it's very difficult. We as Airbus are very bad in collaborating with small players. We are trying to use the same procurement processes. It doesn't work. We are trying to use the NDAs, which are very complicated for such kind of startups. Therefore, we introduced a couple of years back the new model, which I stolen from the BMW group. It was the venture client unit. And the venture client unit is a new way how corporates collaborating with the startups. They are not investing in a startup. They are buying the product which startup has. It's not about early stage. It's about mature stage. We are talking about B, C phase of the startup. It means we have the proof of concept on the table with the small adaptation can be used on our site. And during the few months, we see already huge value from this proof of concepts validation in big organization. And then we can move it to industrialization afterwards. And from Airbus perspective, there are the three challenges which we are tackling. The short term, of course, is the current product portfolio. It means we have to deliver on our aircraft. It means it's all about the operations. The second one is about how we support operational effectiveness of our aircrafts. And then, of course, it's the next generation of the aircraft, how we can develop it, and what kind of the generative tools we can use already today in order to make it work. Let's give a couple of examples. One of example is computer vision-based technologies. We love them because the computer vision-based technologies can be applied relatively easier compared to the others because you need high-definition cameras or cameras as such. And then if you place it in the operations where we have, when we are building our aircrafts, we can already do a lot of stuff about it. And here we have a combination of the own solutions which we are building in our innovation centers, or we are using some startup solutions in order to improve the quality, safety in operations, and where we are looking on the, of course, the effectiveness or efficiency improvements as well. The next one which we have is all about the optimization on the shop floor. It means if we think about the predictive capacity planning. And we checked with our supplier on that one because it was really the challenge for us if you're talking about the million of the parts which have to be coming on time in order to produce aircraft. And the solution to develop with one of our global partner would take about 2-3 years. Therefore, in that case, we look in the other opportunities or other solutions, and then the startup Vidence was providing very interesting proof of concept to us, quite advanced already. And then during 3 months, we had it already running as a POC in our FAL, in our production facility, and it was already bringing about 10% improvements compared to this what we had before. Therefore, from this one small example, we were able to prove that also external solutions coming from the startups, but mature startups, are valuable for companies like ourselves. And this one is now we are rolling out in the different files globally. Another example is all about the data lake, which we created about 2017, because we believe that everything what we do in the future has to be first done on the data side. It means we have to put a lot of the emphasis in order to have a structured data. And trust me, it is not so easy in the companies where the life cycle of the product is not just 1 year, like in mobile sector, or like a couple of years, like in automotive, where there is already difficulty. In aerospace, we are talking about life cycles which are decades. And therefore, many drawings which we have even today, and many data which we collected, it's many times handwritten notes or similar things. Therefore, going from this very analog way to more digital is, of course, a challenge. Fortunately, for all new stuff which we are doing, like, for example, having those aircraft in operations, we are collecting already the proper structured data which we are using for our customers. And here's an example of the data lake which we created 2017, and we call it Skywise. In this data lake, we have mostly we have, as Airbus, flying about 12,500 aircrafts globally, and majority of these aircrafts, about 11,700, are connected to the data lake. And with this, we are offering already services to our customers in order to improve their operation rates with this what we do. And here are the numbers which are showing, or which we are already providing. Improvements are clear and validated with our customers as well. And here in this data lake, we have services, and these services are built already on AI models. It's, if we're talking about the predictive, it cannot be done in different way. It's already AI-based. Another good example about generative AI is this what we do with our satellites. It means we have a couple of satellites, we are doing the Earth observation, and once we are doing it, the first resolution of our satellite is about 30 centimeters. It means you can see quite precisely the thing which is about 30 centimeters. But in many cases, it's not enough. Therefore, what we do with the generative AI, we were able to apply the new algorithms in order to improve this resolution to about 15 centimeters. And it is not about hardware change, it's just about the software. It's just one small thing. Another thing is that once you do the Earth observation, that sometimes the clouds are coming and then you don't see this. Therefore, you have to properly filter it. And also GenAI is helping here very much with this kind of the use case, which as a data afterwards, we are providing to our customers, and then customers, global customers, can use it for the different purposes. Like, for example, observing deforestation of what is happening in different regions, and so on. Therefore, there's a lot of the value which this data creates. Talking a little bit about the next generation of the aircraft will require from us being even more disruptive. It is why I'm very pleased that my title in this company is the Disruptive Research Technology, because we have the opportunity to shake a little bit the tree and look beyond what we would not normally do. And here we are talking about a couple of the things which have to come together. On the one side, we talk about the aircraft design, which has to be designed not just as a product, but this product has to be placed in the environmental concerns. It has to be placed in the new operation schemes, and of course, everything about the new materials, which are going to be also much more digital. And we discussed also during one of the panel, Ray talked about the data value, and the data value between the different ecosystems. Airbus controls own data, but at the same time, we have supply chain, which is about 80% value of this what we do. And therefore, collaboration between us is so important. And then we see already in Europe, in the area of the Katana X, the platform which is going to help exchange the data. The similar thing we are doing on the aerospace side. This is going to be game changer once we have it, because then as an ecosystem, which is an aerospace ecosystem, we'll be able to build various services and then make the monetization of the data at the end of the day. The good example of the generative AI is just a quick one, is, for example, the separation which we build up in the aircraft. You have the small wall there, and this wall, today is a massive one, but it can be done in the more clever way. It means bionic partitioning, and then by using the new generative models, we can deliver still on the same requirements like 16G acceleration. We can do this 3D printing. It means it's designed for processes and materials we would like to be using. And also what is very important, it reduces weight and of course reducing cost during the manufacturing. It is just a small one because in the similar way, the other components on the aircraft are going to be designed and built in the future. I touch on the safety, and the safety is all about adding more smart functions to the aircraft, to the cockpit where we have a pilot. The goal is to empower the pilot, not remove the pilot, but empower the pilot and have the pilot focusing on the main mission. And here, what we do, we are adding the new functions. It means you could compare it a little bit to this, what we happening in automotive, where the compound, I would say the old car manufacturers like VWs, Audis, and you name it, are adding, for example, the more features which are helping you as a driver during drive. The other way is to go top-down, where you have a Tesla which is introducing immediately the full pilot, which not always works. We, because of our responsibility about the safety and aerospace, we are going bottom-up, not top-down in that case. And here we are adding the new functions, like, for example, working on the taxiing. It means the taxi at the airport should be done supported by machine. Or, for example, when you are flying, the automated takeoff or landing should be supported by machine as well. Here we did a couple of the prototypes. The one for helicopters, we call it Vertex, because a helicopter also is flying with one pilot, and pilot suddenly cannot fly anymore. Then the machine can take over and flew the helicopter to the nearest landing pad safely. And similar way on the big aircraft. It means if something happens to the pilot or pilots, then still the machine will be able to bring us safely to the place, to the airport, and land safely. And here, all of these technologies are computer vision based because we have to have the understanding about the environment around us, not just position of the aircraft, but also what is happening during the landing phase and where the airport is, what is the landing free or not, what is happening around. Therefore, here we are using the computer vision methods in order to analyze and understand the surroundings. And of course, a lot of the generative stuff is happening because in order to train the model, which is computer vision based model for such kind of autonomy, you have to have plenty of the data. On the one side, we are collecting the data by flying the aircrafts with the cameras, high-resolution cameras, and then we are collecting them. But then you are not going to cover all use cases. Therefore, what we do as well is we are looking to generate synthetic data. And synthetic data, which we have here, is helping us to filter things like, for example, or generate the new use cases, like with the clouds or weather conditions and so on. Therefore, this is adding to training of our models in order to ensure that we are going to be covering all use cases possible in the case of the flying autonomously in the future. All of this is, for this industry, very disruptive. Therefore, what we have to do, we have to also understand, if we think about, for example, hydrogen aircraft, or if we think about autonomy, what is the customer, I would say, what the customer thinking about applying such kind of a technology is going to be. Because at the end of the day, it's about the customer acceptance to accept these new technologies once we are bringing them to the aircraft. And therefore, we started also some gamification here, work with a couple of the research institutes in order to create the game, which if you have some time, you can play. It takes something like a few minutes, where you are going to be answering questions about your willingness to the new technologies and so on. Then you are going to be seeing what is your score against the other people. Are you more disruptor or early adopter, or you are just normal person? like sometimes happens. And with this, we have already many thousand answers, which are coming from the global network because we are spreading this game everywhere. And this is going to help us to make the better judgments because the combination of psychology and sociology is going to give us better tools in order to predict where we should be introducing such kind of new technologies, in which regions, which region is more, I would say, disruptive compared to the others, and this will help us as a company in the future to make the better choices and decisions. And AI is already today. We have it already for many years as a machine learning, and now AI and Gen AI is coming with a lot of challenges. Particularly if we think about the safety systems, embedded system into aircraft, we have to ensure that we understand what the machine learning model does, or what the LLMs, whatever we are going to be introducing, are doing. Therefore, there's a lot of the challenge behind which we are working on. And the AI, Gen AI, probably would be not enough. Therefore, what we are looking after is how we can introduce the next generation of technology, quantum-based, with the AI together. And here, we believe that, for example, by using quantum and Gen AI, we'll be able to train the models with less data. At least this is the assumption which we see. Therefore, we started something like end of last year together with BMW, the Quantum Challenge. It's a global challenge which is going to be finalizing now by end of the year, where we have the different use cases from automotive and aerospace coming together. And there are a couple of the finalists now, and we hope by end of this year we know who won the prizes in different categories. The one particular category which is very interesting to me is enhanced autonomy. And I was last week in Tokyo University, which are one of the finalists, and I work with these guys to see how great team they have in this area, because it's not the one place in the world which can solve our challenges. We have to collaborate together in order to find the best balance between small, big, local, and global ecosystems. With this, guys, I would like to thank you very much. And 2050 is going to be a time where we are going to see this industry decarbonize. Thank you so much.
Thank you.